hi everyone, and like Swanan said, I'm also part of the team that's organized this, so I want to just say it's really awesome to see like this huge crowd on a Friday morning in Bangalore. So what I'm speaking about today is native extensions in Ruby. The title of my talk is Native Extensions Served Three Ways. About myself, I'm Tejas Deinkar. I'm a partner at Nilenzo Software, which is an employee-owned collective, and it's a really fun place to work. If you want to know more, catch me tomorrow. On Twitter, I'm Deinkar, and on GitHub, I'm GJA. You can find most of my open source contributions over there. So about my talk, this is actually a pretty technical talk, and so expect to see lots of code. I hope to have 5 minutes for questions. I'll try to beat like Satish and beg for it, but like if I don't have time, just catch me in the hallway or whatever, and I can try to answer whatever I can. So I'll mostly be covering C extensions, FFI, and Swig. And yeah, so let's talk about first why you would even want to do, why you would ever want to build a native extension for Ruby. So there's a bunch of different reasons. So number one is to maybe integrate with new libraries. Say like a new database has come out, like for example, libdrizzle, which was a new library that came out to work with MySQL and the Drizzle database. You might want to port that over to Ruby. You might want to improve performance of critical code. There's different ways of doing this, of course. You could like try doing JRuby, look at different caches, but sometimes you have an algorithm that you just want to implement in native code, or there's already a great library that implements it. Someone was giving me an example of CSAT, I think, which Bundler could have actually used to, or could use to kind of resolve gem dependencies. So that's written in C++, and sometimes you want to just move that there and to improve performance. And of course, you want to write code that works across different languages. And in general, it's a lot of fun. You know, like real hackers program in C and all that stuff. So you could just feel super elite by doing this. So before we talk about native extensions, I'm just going to take a small segue and ask. So let's talk about Python a little bit. Like, how many people in the house are are Pythonistas? How many big Python fans? Well, that's actually surprisingly small. I thought there would be more. But so I've actually figured out the best way to write Python code, and I'm gonna tell you this right now. And yes, of course, I am trolling you. So over here, I have a Python interpreter open, and I'm going to say import Ruby. Yeah, that seems innocent enough. And I'm going to say ruby.eval foobar.size. That seems to return 6, so that seems to work. Let's try something more complicated. I'm going to say ruby.eval. I'm going to define a method, factorial. And def factorial n partial n equals 0, partial factorial n minus 1, etc. Yes, it's tail recursive, I know. And finally, I'm going to call it, and I'm going to say ruby.eval factorial of 5. Yet again, you'll see that I actually get the result, right? So wow, what is this? Have I implemented Python in Ruby? Let's look at the code which actually makes this happen. How can I actually make this work? Well, surprisingly, it's about a dozen lines of code. I know this might be a bit hard to read from the back, so I'm gonna read out the interesting bits line by line. So it's about a dozen lines of code, but let's remove all the Python stuff and let's just look at the Ruby parts of this. It's even a lot less, yeah? So let's go through this one by one. I start off by including ruby.h. Ruby.h, for most of you who are familiar with C and C++, .h files are header files. They basically have the definitions of the various constructs that Ruby, or like whatever, that your library exposes so that you can, so that your compiler knows what definitions exist in the first place. So any Ruby extension that you write, you'll need to include ruby.h. And most of the time, this is completely sufficient. You don't need to include anything else. So let's start looking at the actual code. I have a method called Python Ruby eval, yeah, and it accepts one parameter, which is a string. Okay, nothing complicated there. What I do next is I take that string and I pass it to a function called Rbx eval string, right, which stands for Ruby eval string. Nothing really magical over there. All I'm doing is I'm calling Ruby's eval, and you'll notice that the Rbx eval returns a object of the type value. This value is actually very important. The same way in Ruby, every single object inherits from object. the corresponding construct in the C Ruby extensions is the value object. Value object is used to represent every single Ruby object from nil to true to false to every single custom object. Fine, so I have this value object. What am I going to do next? Well, what I'm going to do is I'm going to switch on the type of the object. Yeah, there's a macro called type. And if it's a fixed num, fixed nums are numbers in Ruby, I'm going to call fixed num to int to just convert that to an integer. If it's a string, I'm going to call string value pointer, which converts from a Ruby string into a C string. And if it's some other type, like if it's an array, yeah, I could have implemented this, but yeah, I'm too lazy right now, so I'm just going to say return none, which is the Python version of nil. So yeah, that's pretty much it. That's all it really took to kind of build a small kind of Ruby module, which would extend some of the functionality of Ruby into Python. Let's look at something that's like another construct. I don't want to build all my code, and I don't want to eval all of it. Let's say I want to require a file. Well, it's pretty much the same. All I need to do is I accept a file, and I do RB require on that file. Yeah, so in general, yay! Like, actually, in that 12 lines of code, you really have built your first Ruby extension and your first Python extension. So what I'm really trying to call out is it really is that simple. Like, as Ruby developers, we always have a lot of fears of like, oh, this very simple thing in Ruby, how can I even do it in a C extension? It turns out that the Ruby C extensions are great because they expose almost everything you would ever want to do in Ruby. It exposes the same thing in C, right? So let's look at why aren't we doing it more? Well, the biggest common fear every time anyone mentions C to a Ruby or in general high-level programmer is, what about the memory allocation? Like, how do I handle this? Well, as it turns out, it's really not as difficult as you might think. And since you are still programming in the Ruby world, you actually have a lot of things that can actually help you. In particular, there are these two macros, right? The first one basically takes a C pointer and stuffs it inside a Ruby object. You just tell it which class you want that Ruby object to be, and it will magically be created with your pointer. And the second one gets the pointer out. What actually happens internally is that your memory that's been allocated has been tied to this Ruby object. And when this Ruby object gets garbage collected, so does your pointer. So in many ways, you're basically just reusing the Ruby's GC to manage your native code as well, right? No batteries included is the next big fear. But just keep in mind that since you are programming in the Ruby extension, in Ruby extensions with C, you actually have access to every single piece of functionality that Ruby can provide you. There are methods to manipulate arrays, strings, hashes, you name it. It's all very easy to manipulate even in a C extension. And of course, portability. I have no idea what this comic is about. It was on Geek, but it was the first thing when I found search for portability. Most C extensions work only in MRI, except they sort of work in Rubinius. Like Rubinius has tried to make be sort of API compatible, but it sometimes works, it sometimes doesn't. But so basically, all you can trust if you're writing a C API is that your gem is going to work in MRI. So what if you do want to? And the last concern I've always seen is how do I even get started? What is the best practices? How do I build a C extension? For this, I've always found that the Ruby source code itself is probably the best documentation for how to build a C extension. It's actually very simple, very easy to understand, very nice to read. So over here, I'm actually showing you string.c, and I'm going to walk through a few lines of this code now. Okay. So the first line is a method called init string, right? This is the equivalent of main for your Ruby extension. Whenever your gem is required, it is going to call this function. So if there was a gem called string and I said require string, it would call this method init_string. Yeah. The first thing I'm going to do over there is I'm going to say RB define class. I'm going to define a class called string, which inherits from object, right? That's exactly equivalent to class string, less than sign, object. Nothing complicated there. I'm storing this in a variable called rb underscore c string. Yeah? And then I'm going to define a method on rb underscore c string called eql question mark. Right? What I'm going to tell it is that this method, when somebody calls eql question mark on any string, call this C function, which is rb underscore str underscore equal. Right? Still nothing complicated over there. And the last thing says that I expect one extra parameter to be there. Self is always passed, but I want one extra parameter. So those are the 4 simple parameters to this. There's your class name, your function name, the C function to call, and the number of parameters. Still nothing really complicated. Let's look at the actual implementation of the function. Really simple. If self is equal to str of 2, return true. Yes, they're the same object because the 2 of them are the same object ID. They have the same object ID. They're actually the same object. Similarly, if the second one is not a string, that is, that the type is not a string, return false. Simple enough. And the last line kind of delegates to the old Ruby equal, which will do the algorithm most of us have learned in high school, where you compare string by string, character by character to figure out, are these 2 strings equal? So as you can see, there's really nothing very complicated in building C extensions. And most of the time, your architecture sort of looks like this. You have the Ruby, you have native code on the left. This is the code you kind of want to run. And you have Ruby code on the right. And this is the code that you want to consume, the code that you've somehow built. In between in purple is a Ruby-aware native code. And why do I say Ruby-aware native code? Because you've still written this as native code. It's still written in C. It's still compiled down to a .so file or a .dynlib file on Mac. But it's Ruby-aware. It knows how things work in Ruby. Compared to this, FFI kind of does the opposite. Instead of Ruby-aware native code, what you have is native-aware Ruby code. Right? So what this means is with FFI, you're basically working purely in Ruby, which somehow understands how the native architecture of the system. Okay, so FFI is a Ruby DSL. It's really easy to implement. It's even easier than MRI, than the C extension. It actually works across all Ruby implementations. I would actually say that all the Ruby implementers got together one day and said, how can we make something that will make it easy for us to integrate with libraries? So it works on JRuby, it works on MRI, it even works on MacRuby, MacLib, Rubinius, you name it, it works. And it basically converts to and from C primitives for you directly. So let's look at an example. I'm just taking the example straight out of GitHub. This one's not complicated at all. All I'm doing is I'm saying require FFI. I'm saying this is an FFI library. My module is FFI library. And I'm saying it attaches to libc. Yeah? And by libc, that doesn't imply that the library is written in C. What that means is this is the C standard library that you want to connect to. And I'm creating a method called puts. And I'm saying puts takes one argument, which is a string, and it returns one argument, which is an integer, one value, which is an integer. Really nothing complicated over there. This creates a static class method or a module method on this module. So I can say mylib.puts hello world using libc. It's very, very easy to attach to a function using FFI. And let's just quickly look at another example. This one, I'm attaching pow, which takes 2 doubles and returns a double. And you can see it in action over there. It works. And here I'm attaching to libm, which is the math library. So actually, FFI supports a lot of built-in types. It supports integers, characters, and for everything else, every single pointer type that you would use in C, it supports, well, a pointer. Yeah? So in general, FFI is probably your best solution for everything. If you're trying to build a new gem, and you want people to use your gem, and you're not just doing it for fun, you probably want to build it using FFI. It also lets you do your modeling in Ruby, so which means the deployment's also a little bit easier. You don't need to struggle with makefiles and other stuff to kind of build that extension. Unfortunately, one piece of misinformation that seems to be out there is that FFI, if you build it with FFI, you do not need to worry about garbage collection. That's actually not true. You still do need to worry a lot about garbage collection. I'll show you an example in the next slide. And unfortunately, with FFI, there is no C++ support without wrapping. So you can see over here that these functions that we've attached to are all static functions in C. They kind of are not attached to any objects. They take a fixed number of parameters. So that's not okay. So that's not possible to wrap C++ functions directly. You could write a thin shim, which kind of takes, which is static functions, which you can use to call your C++ functions, but it still starts getting to be more effort, and you need to write that in C or C++. So you do still have to worry about garbage collection, however, with FFI, and I'll show you a quick example where it matters. So most people will write code that looks something like this and not worry about it. So I have a def run query which will crash. I'm saying db connection is equal to my FFI module.database connection localhost, and my FFI module.database query. I'm passing it the db connection, and I'm saying select star from users. This will probably work most of the time, but in reality, that db connection will eventually get GC'd, right? And internally in C, your cursor will probably hold a pointer to your DB connection, even though this has not been exposed to you via the API. So when your DB connection gets GC'd, or like when the Ruby object gets GC'd, the pointer is going to get GC'd in memory. And then when your cursor tries to access the DB connection, it will crash. Yeah? So the standard pattern for solving something like this is to make sure that these two objects are aware of each other in the Ruby world. In general, what I've seen happen a lot is you save the database cursor, and you kind of just say cursor.db connection is equal to the other connection, so that this has a pointer in memory in Ruby as well, which corresponds to the C pointer. So it's not as if you can just blindly take a library and just looking at the APIs just do this. Although granted, with the very primitive types, when you're looking at things on the left side, the characters, the strings, you're less likely to face big memory problems. So that's mostly all I'm going to speak about FFI. So if you look at the progression we've made, we've started with gems that work in MRI. We've moved on to gems that work in all Ruby implementations. Now let's talk about gems that work on all programming languages, and soon we'll talk about taking over the world. So Swig is sort of the answer to that. Swig stands for the Simplified Wrapper and Interface Generator, which is a big tongue twister. So basically what Swig does is it lets you annotate your C and C++ header files. Architecture is sort of like this. There's native code over there. There's some magic in between, and then magically you get Ruby code and Python code out of it. So let's look a little bit about how this magic works. So Swig works off an interface file. What it basically is it's an annotated header file, and it auto-generates code to make it work in your various languages. And how it auto-generates that code depends on every single language. So for C, for Ruby, it builds a C extension. So maybe it won't work in JRuby, but for Ruby, it actually generates C code, which will call your library. For Python, it's actually a C and a .py file. For Java, it builds a JNI interface. And of course, you still will have the same GC problem that you had while we were discussing FFI. But in general, Swig actually works pretty well. There are a couple of Ruby gems out there that are built using Swig. I've seen it actually used in practice for like a large company which had an algorithm it wanted to share across different programming languages. They had a Python, a Java, and a Ruby sort of front end. So what they did was they built their code in C++, exposed it via Swig, and were able to use it in all these three different languages. It's really simple. So over here we have a class called rectangle, which has a length and a breadth, and a constructor. and a method called area, which I'm sure most of you guys will know the implementation of this. All I need to do is add some junk at the top and the bottom, and oops, yeah, no, that's it, and magically it will kind of work. So on the left, I had said this is a module called shapes that translates in Ruby directly to a namespace. I just need to say require shapes, rectangle is equal to shapes.rectangle.new, and so on and so forth. So with Swig, it's very easy to quickly kind of generate interfaces across multiple different languages really fast. And you can do this if you are, especially if you're the maintainer of the actual native library. So like, if you are the maintainer of the actual native library, I would recommend going with Swig. So there are other options as well. Ruby has no shortage of ways to include native things. I think an old one, which has been around for a long time, is dynamic load. That is basically the port of C's DL open into Ruby. It's been around since forever, but I've heard a lot of reports of it being really buggy. And in general, I think both that and Fiddle, which is now, Fiddle is actually come in Ruby 2 or Ruby 2.1. That is, again, another way of introducing native libraries. Both of these kind of work in concept very similar to how FFI works. So I'm not going to spend a lot of time covering them. I think Fiddle may start becoming popular soon as more and more people start using Ruby 2. And I don't know if FFI and Fiddle are someday going to start merging together. But in general, these are the other two options. So OK, TLDR. Native extensions are fun, really easy to build. The three big tools, which are C extensions, FFI, and Swig. You probably want to choose FFI if you don't maintain the library, even if it's like it's too easy to write the code for it. And Swig, but Swig may be better if you actually maintain the library and you want to expose it to a number of people. OK, thank you. I think I actually have time for questions. How much time do I have for questions? 10 minutes. That's a lot of time.
For questions.
OK, so does anyone have any questions? Yes.
So when you actually write the native code, right, do you have to take care of doing the GAL, acquiring GAL and releasing it yourself?
So actually, that's actually kind of an interesting question. I think that like when it actually calls the native extension, that's all the code you write would be considered a single Ruby call. So I'm not actually sure if the GIL is held for the entire time. I think by default the GIL will be held for the entire time your code is being executed.
Okay.
Unless you say do something to create a thread and move out.
Right, but when you are writing, especially things like the database connection, right?
Right.
When you have that kind of a
okay, the database connection.
Yeah, like when you have anyway, when you have that kind of a code, right? It's not very. You would assume that somebody might have done a thread.new and gone ahead and called these 2 lines of code. Right. Which means like if you haven't taken the global interpreter lock yourself, then the chances are the same problem that you said about GC might occur. Like you might get preempted and then horrible things might have happened. So does that mean every native extension that you write needs to take GAL because there is that obscure case of somebody doing it in a new thread?
So actually, so in theory, I think yes. When the code, so most native extensions, let me just go all the way back.
Yeah, go to your C code.
Yeah, this one. Yeah.
Yeah.
So I have over here a method called static value RB str equals.
Right.
Right. So what Ruby will call this automatically when I say string.eql some other string, and as long as the code is in this method, you will be holding the GIL. I don't think anyone else can execute code during this time unless. Actually, I'll need to get back to you.
Okay.
Let me check.
Yeah, I mean, sure. Yeah, this was something that.
Okay, sure.
Yeah. Okay.
Yeah. So, like on the same note, actually, I just want to add, like your C extension, you only acquire the GIL if in your extension you are going to run something a long-running thing. that you don't want the control to return to Ruby. For example, let's say your C extension takes an image and it does some image processing actually, and you don't want you just want the C extension to write the file to the disk and call it a day. You don't want to return that something to. Then you acquire a GIL in your extension, and then that thread will run completely separate from your thread on which Ruby VM is running actually. So that's the only time when you will acquire a lock. If you are passing any data back to Ruby, or any way you pass the control back to this thing, then you don't want to acquire the JL yourself actually. There are constructs for that, but it's generally not recommended.
Yeah, so I believe what he's saying is correct. I think I was slightly mistaken. I think the GIL is only acquired when you enter the function. As soon as you enter the function, the GIL is released. Unless that's correct, right?
Correct. That's correct.
Yeah. So so I guess if you actually call anything that's a Ruby construct from here, so you can actually call a method from within your C function body. I think at that point you'll need to reacquire the global interpreter lock. But GnuFight is correct that the GIL is only caught when you enter the method.
We have time for more questions.
Hey Tejas, how do you test native extensions?
Okay, so like I said, the architecture of most of your things is sort of like this, where you have native code, Ruby-aware native code, and your actual Ruby code. Presumably, you're doing something like a Google test or something to test your native code. And to test your actual Ruby code, depending on what your library is, it will vary drastically. So for example, if you're writing something that connects to a database, you may want to actually stub out the things that actually call, say if you're implementing it with FFI or even with a native extension, if you're making something like a database call, you may actually want to mock out or stub out the actual implementation that connects the two. But if you're doing something that maybe is not so intensive, maybe something like a JSON parsing library, what I would recommend at this level is actually writing an integration test. Actually pass it JSON and make sure it actually returns you the actual a representation that you expected. So the answer to how do you test this actually varies very drastically. And I've seen like different maturities of tests across like all of them. Does that answer your question? Okay. Anything else? Okay then, I guess that's it. Like, thank you so much, and yeah.